Hello everyone, my name is Zan Markan, and today I will be sharing a few things with you about delivery patterns for platform teams. Of course, I'm talking about software delivery patterns, but yeah, let's crack on. So, before we go into the main part of the presentation, let me just open up with a story. So, a long time ago, 9, 10 years ago, I was working in this mobile team for a large enterprise, and I was working on the Android team. We had our colleagues on the iOS side as well, building this kind of customer-facing application used by millions of people every week. So pretty sizable usage, pretty sizable application. And we were following kind of the DevOps principles to the letter, or to the spirit of the letter anyway, where everyone was involved from the beginning, from product to QA to release managers to obviously the engineering side of things. We had everything tested. Everything was also automated, from unit tests, integrational tests, end-to-end tests, before it obviously ultimately went into the release process. Releasing on mobile is a bit peculiar, so we're not directly touching people's phones. We are sending software to a third-party store. That could be Google Play Store in our case, or the Apple iOS store, or there could be many other Android-specific stores. Anyway, we were just focusing on Android and iOS, the main stores, and we were working on features most of the time, obviously. And one of the features that we were building was called the drop lock. So what the drop lock did, it allowed us to disable the applications remotely without doing an actual kind of release that takes a review, etc. We could do it through this kind of central configuration mechanism. Why would you want to disable the application? For example, if the API you're relying on falls down, you want to handle this gracefully and show customers some nice message saying, hey, we'll be back shortly, or this is what's happening, or something similar. So we decided what we're building. We agreed with my iOS counterparts and the product people and the QA people how this is roughly going to look like. We decided to utilize our existing kind of remote configuration mechanism that loads at the start, and then we built it, and then we tested it. We had unit tests, we had integration tests, we had end-to-end test. This was considered part of the critical path. So yeah, everything was utterly and thoroughly tested, and we were happy with it. All we needed to do is, of course, wait for an actual outage to test it in production. And that outage obviously happened at some point. We had a global incident, and obviously we needed to take those apps down immediately. At which point, when we decided to take them down immediately for our global customers, the apps just started breaking. So we didn't fail gracefully, we just broke. Turns out that while we had both flows tested end-to-end, the critical path individually, we didn't test them together. So when both applications were taken down at the same time with the same configuration file, they both started crashing, which is not something we wanted to do. It was also probably the only post-mortem I was ever involved in where we debated why the app why we couldn't actually shut down something. So yeah, it turns out that yeah, we had misinterpreted some of that configuration logic between our teams, and essentially the configuration was clashing on one or the other side. When we managed to bring it down gracefully later on. And as a result, we set up this process where we both owned this kind of central configuration as a product, as a platform consumed by individual applications. So everything was then tested with both platform in mind at the same time, consuming this kind of central configuration. So yeah, and that's just one outage story, that's just one incident story, but I'm sure it feels familiar or sounds familiar to many of you. Because like whenever we start writing software, it's very simple, right? There's few features, there is very little code, everything is greenfield, if you will, and we like it. We can move fast, we're not going to break things, and things are easy. Things can be done right. But then months pass, years may pass, and the software gets bulkier and bulkier, and your automation gets bulkier and bulkier, the automation that you rely on to build, test, and ultimately release the software. It's sort of like your blade of Damocles. Of course, your application is more and more valuable because yes, you have more features. It supports more users. It supports more use cases, but it's also more complex. Complexity means fragility. And just as the sword of Damocles, when it was hanging over Damocles' head, when he was sitting on this king's throne for a day, was very uncomfortable for him because he was always at risk of that thing falling down. It's the same with our software that we're building and our automation that we have in place. But fret not, the answer to fragile automation is, of course, more automation. We can not only make that sword bigger, sharper, more high-tech, and hanging on an ever thinner line, we can also mitigate some of the risks around that and allow us to move away faster and more effectively if something indeed does break. But yes, we can mitigate, but it's still there. Anyway, my name, as we said, is Zan Marken. I work as a developer advocate at Circle CI. I'm based in London, and I've been working with software for over 10 years now, and building it, breaking it, you name it. Circle CI, what we are, is a CI/CD platform, the leading, most advanced CI/CD platform in the world. And we have customers and users who are bigger, smaller, larger, enormous teams in varying organizations, in pretty much every organization, any industry you can imagine, working, building, verifying, and releasing their software on our CI/CD platform. And through my day-to-day job, I get to speak to many of those teams, whether they are product teams or more commonly, they might be DevOps teams, they might be infrastructure teams, they might be even platform engineering teams who are responsible for their whole organization's pipeline effectiveness and experience, if you will. And they are solving big challenges on a daily basis around how best to build, test, and deploy and deliver their software for their teams. And when I get to learn many of their new use cases, new ideas, I then take them, extrapolate some of them as patterns, and then present them to you. So yeah, today I'll be presenting you some pipeline patterns for software delivery aimed at platform engineering teams. So why platform engineering? So if you have a large engineering organization, let's say dozens of teams, you often want to standardize certain aspects of it so that it's easier to spin up new projects, to move between projects. and reason about the resources that you have at your disposal. So that's where kind of platform teams come into play. They are used to standardize or create this unified environment so that product development teams can move faster. So essentially, your product teams are your customers. You're building for their success and for their effectiveness. And of course, in more complex organizations, the regular, quote unquote, build, test, deploy that CI/CD is most often known for is just an insufficient pattern. You want to orchestrate between multiple dependencies, between multiple software projects, and build things so that everyone can ship as fast and effectively as possible. And they said you want to create some constraints, so limit the amount of the types and amount of software and services that you're relying on. So maybe you just limit your CI pipelines to Circle CI. You just limit your artifact management to Cloudsmith. You just limit yourself to single cloud provider, so that everyone gets to use single platform to the best of their abilities. And you also kind of build this internal center of excellence, expertise around these platforms and your ways of working. It's not only tools, it's also behaviors, the flows. So every single deployment flow has something in common, especially when looked at it from a single organization's perspective. Usually also standardize things like nomenclature, so like naming conventions, which are very important when you want people to move between different projects. You want to kind of reason around ownership of cloud resources, etc. So yeah, that's why delivery patterns are very, very important, especially in large engineering organizations. So yeah, let's look at a few and see how and why they might come in handy with you. The first one, and probably the most important one, and where everything begins and ends, is using the APIs. So every tool that you can imagine probably has some kind of dashboard, some kind of UI that you can just click through and get some value out of it. It could be a significant amount of value out of it. Like we bundle things like insights for your pipelines, where you can just gauge which pipelines are more successful, more frequently successful, less frequently successful, highlight things like flaky test, etc. But there's inherent limitations to dashboards because they're trying to cater to pretty much everyone. So I'm talking about the built-in dashboards that tools bring themselves. Oftentimes, these kind of central platform engineering organizations will build their own UI-based tooling, dashboards, UIs for provisioning software, for releasing, that kind of uses underlying services APIs and orchestrates them in an advanced way so that it just makes sense for their own organization. What we're also seeing is we're decoupling pipelines beyond only push, commit, push, and build, right? So this is not the only trigger anymore. We can now have our pipelines call other pipelines, integrate with others, respond on different events from outside. I'll talk about that a bit later. But ultimately, the gateway for that are your APIs. It's the tooling that you build on top of that, from that. For example, I'll give you another CI/CD example. If you have a pipeline, the regular flow is you commit, you push, you build. Doing that, the CI/CD platform only has information about your branch, about your commit, about who triggered it, and that's about it. Maybe also a tag if you're doing this from a release or a tag deployment, or maybe a pull request, but that's about it. But you could even create additional kind of variables. We call them pipeline parameters in your pipeline, so that you can drive a specific workflow for a specific subset of your features, maybe for a specific platform dependency that you have, and integrate that with something else. For example, a chat tool. So your main team's Slack tool could be used to invoke pipelines and give you artifacts back from a single chat message to it. And that's the power of APIs, and especially in software delivery. So as we've kind of established that it's great to use APIs to automate everything, we also need to take a step back and acknowledge the fact that sometimes we want to make some manual decisions, make some manual interventions in order to have greater assurance, greater confidence, and also potentially compliance with regulatory requirements. Sometimes automating everything is just too risky, and you want to have this kind of single person who decides this should go ahead. We should release this new feature. We should toggle these feature flags to released, to start showing them to the users. Sometimes you want to have a fine control over stage rollouts. That's when you're going to release first, for example, 10% of users, then grow that to 20, 50, all the way to 100. And sometimes you want to have someone looking at the crash reports, looking at the metrics, saying, okay, this is good to go now, and promoting it manually. I like to think about this in the way that you automate everything to the point of some crucial action that has to be done by a human. And that human, that delivery manager, that security engineer, security manager, who needs to have in-person view of everything that's happening, you can still automate getting them all the resources they need. So all the commits, all the Jira tickets you're working with, all the reports that you're generating through automated testing and validating processes, which are part of your pipeline, and just serving it to them, maybe messaging them on Slack or via email, so that they're immediately notified with all the resources they need to make a quick and effective decision, and well-educated decision as well. That's where a manual intervention could really come into handy in an otherwise automated process. Sometimes you want to do things at night when no one's around to see them, but they also don't have to wait for it. That's why we have these things called the notion of nightlies or nightly releases. They're mostly useful for expensive tests. For example, if you have like a comprehensive test suite I want to run for hours on end, and you don't want to wait for that in your kind of standard development flow. But also we often see them in especially when developing libraries or other dependencies. A nightly can basically run at night when no one's working, no one's developing. Cut it from the main branch, so you have the latest changes taken and ready for further development in the morning. Or maybe you can have it build a kind of full test release of the software, deploy it so that when the QA starts in the morning, they can start with the latest version. Again, a very useful tool in your arsenal. And here we get to my favorite, or the most powerful thing in the whole presentation, are event-based triggers. If you think about your kind of Git workflow, so like you commit, you push, it triggers a CI/CD pipeline, triggers the release. There could be many more sources of these events. They could be obviously chat messages. They could be observability tools telling you, hey, the thing that you released yesterday or an hour ago is having more issues than the previous thing that you released or that was in production. Maybe you want to rebuild, retrigger the previous version and get that back into production. That's called a rollback. And I think that in the near future, I mean, year, 2, 3 years, we'll start seeing these more and more. This is very new stuff, right? This is not often used yet, but as we automate more, we will also see automated rollbacks so that failed deploys, failed releases get reverted automatically, or maybe even just flagged with the responsible person, and that person can then manually trigger the rollback. But again, give them all the resources they need. We already are seeing these kind of canary strategies for releasing. So you release to 5% of people, 5% of users, 5% of traffic, whatever it is, and then that's served as your canary. If that's seeing the similar level of stability as previous versions, or obviously improved stability, you will then automatically promote that to a greater audience, or revert that automatically. So that's more like a rollout scenario. You could even have your observability tools communicate with your feature flagging tool. So you don't need to make a release, make a deploy if you just want to shut down a particular version of a feature or change a flow, for example. So these are all event-based things that I think that we will start seeing more and more. At the moment, they're very bleeding edge. Okay, so now that we kind of covered a few of these more advanced patterns, let's just leave you with a few parting thoughts. So build, test, and deploy is not where we can stay forever. We need to get more out of our CI/CD pipelines. We need to get beyond this kind of commit, push, CI/CD flow, and start thinking about software with more increased dependencies, increased complexity, and orchestrate it in accordance to that. These patterns that we covered, they will allow organizations, and do already allow organizations, to streamline and automate their own processes, the way they work, the way they are releasing software, the way they are thinking about releasing. And ultimately, as platform engineering, platform organizations become more and more prominent, they are enabling them through development of technology to do that. So to enable, to use those streamlined processes to achieve everything that they want to achieve. Most organizations are somewhere on this journey. A lot of them are, like, very few are using kind of these event-based triggers to do automated rollback and stuff like that. Most of them are somewhere between. They're somewhere on this journey to platformize everything so that, yes, their engineering organizations are more productive, more effective. And with that, I will thank you for your attention and give you the stage back to Alan. Thank you so much.